All right. So unit 2, we're getting into radical and rational functions. So radical functions first, guys. We're talking about square root stuff. So those are radicals. Like square root, cube root, fifth root. That's what we mean when we say radical functions. So just as a little bit of review, I think you guys are pretty good with this though. Remember that you're not allowed to take the square root of what kind of number? Negative, right? You can't take the square root of like -2. What about the third root? Can I take the third root of -2?
Yes.
Yep, that's fine. Yeah, you're allowed to do that one, right? What about the fourth root of -2? No, you can't take the fourth root, right? So what's the pattern there? You can't take, yeah, it's like the even and odd thing, right? So I can't take the square root, or the fourth root, or the sixth root, the eighth root. You guys remember why that is? Yep.
Well, because a negative number to the power of 3 is still a negative number.
Yeah, exactly, right? And it comes from this, is that -2 times -2 is what? +4, right? So if I take, so that's going to work out. If I go -2 times -2 times -2, that's going to be -8, right? So I'm allowed to go the cube root of -8 because that's just -2, right? So that one just works out. But if I said, what is the, let's say, the square root of -4? Well, what does that even mean, right? Because 2 times 2 was equal to 4, and -2 times -2 is equal to 4. So what would it even mean to say the square root of -4, right? Like that doesn't even, it's like nonsensical. It doesn't even make sense, right? Other than like there's a whole like branch of math where you do take the square roots of negatives, and they're called like imaginary numbers. But yeah, that'll be a university course for you guys. Okay, so let's sketch the following graph and state the domain and range and x and y intercepts for just our standard y is equal to the square root of x. Okay, so square root of x, so what we can do here, we're just gonna, we know that it's gonna be starting at the origin, the point 0, 0. And then when x is 1, what would y be? For y is equal to square root of x. Yeah, well, if I threw a 1 in there, that'd be the square root of 1, that would still be 1, right? If I threw 2 in there, so if I threw 2 in for x, that would be the square. Well, let's do a different one. If I threw in 4 in for x, so when x is 4, what would y be? 2. So if I count over 4 and go up 2, there I am there, right? And you can kind of see our pattern that we got going now. Just want to be there. So you'd have a line kind of going off on the side like that, right? This is still following that same pattern, if you want to sketch this quickly, that it goes, well, in this case, it goes up 1 over the odds. So like up 1 over 1, up 1 over 3, up 1 over 5. Right? So you can like do that kind of quick and easy instead of putting them in every time. Okay. Oh, shoot. All right. So the domain of this guy, domain is going to be x has to be greater than or equal to 0, right? Anything to the right is 0. We'll say the range has to be, y has to be greater than or equal to 0. And what about our x-intercept? Yeah, so our x-intercept is going to be at the point 0, 0. And the y-intercept would be also at 0, 0 as well, right? Starts from the origin. Okay, so the reason why we went through that is because that's kind of like our base, right? We're just starting with that base function. So on the next page here, this should all look really familiar. So transformations of radicals. So we have it written out with the square root, but this actually isn't anything new. This is just the formula, or on your formula sheet there, right? This is just y is equal to a f of, what was that written there again? I think it was square bracket. B x minus h plus k, right? That's the same thing. We're just replacing the f of x with the square root function, right? So then everything's the same. You guys just wrote an exam on this. So all the parameters of A, B, H, and K are all going to function exactly like they did before. So I'm not going to spend much time or any time going through these. If you want a reminder, here's your parameters for each of those. But like I said, it's exactly what we've been doing. So I'm going to just jump into a few here. So it says, state the transformations, the new domain and range, and the mapping notation for the following equations. Graph them if you need assistance. I'm going to skip to maybe the tougher ones. Maybe we'll just do E to kind of remind ourselves how to do this. Okay, so we want to write out, like, vertical stretch of, horizontal stretch of, and then mapping notation. So let's rewrite this thing just so I can see it a bit more clearly. I'm going to rewrite this as, I'm going to move the 5 over to the right side. I like looking at it when the K value is the same as the equation. So I'm going to write this as y is equal to 2 times the square root of, all right, now here's the question. Is this in a good form yet, the way I'm looking at it? What can I not see? I can't see the B, right? I can't see the B the way it's written. So I need to factor out a 3, right? So we're going to factor out a 3 first. Can you see? Yeah, okay. All right, so 3, start my bracket. I've got an X. And then what's this going to become? 1 over 3, right? Because what we're doing is we're dividing out a 3. So it's still minus and then 1 over 3. Okay, and that was the whole thing that was underneath the square root, right? And then remember we moved the 5 over, so it's plus 5. Okay, so then this thing has a vertical stretch of what? 2, yeah. Has a horizontal stretch of, yeah, 1 over 3. Opposite of the B value there. It has a horizontal translation of, it's still 1 over 3, yeah. That one, we're not doing the inverse of this one. This is just left or right. So 1 over 3 to the right. If you want to, if you like just going positive, fine. If you like saying 1 over 3 to the right, you can write that out if you'd rather. And then lastly, we've got a vertical stretch, or vertical translation, sorry, of 5 up, or positive 5, or plus 5. Okay, so let's write out our mapping notation. Actually, you know what? Let's do domain and range here first. Let's go domain. So we'll go with the domain of this one would be, all right. And then while I'm doing this, I'm kind of keeping in mind what our original function looked like. So that was the function y is equal to the square root of x, right? Was that one there? Now, if I'm looking for the domain of this one, right? Domain is talking about my values in the x, or like my x values, right? So when I'm looking at like all these things that we wrote down there, do I even care about any of the vertical things? No, like when I'm looking at domain here, I'm just doing the left and right. So all I really care about for this one is that we have a horizontal stretch of 1 over 3, and then we have a horizontal translation of 1 over 3 to the right, okay? So, so x in this case would be, well, if we took our point 0, 0 right now, right? And we multiplied that by, like the x part, if we multiplied that by 1 over 3, what would it be? Still 0, right? So the stretch part of that didn't affect it at all. But we do have a horizontal translation. This thing is moving 3 to the right. So my whole graph has moved over 3, like a third to the right. Like I know that. Like whatever happened, this thing moved over to 1 over 3. So I know my domain has to be x has to be greater than or equal to 1 over 3. Oh, that was weird. 1 over 3. Good. Okay. So then the range here, what happened to our range? So imagining again the blue graph up here. 0, 0. So what happened now? So our vertical stretch of 2, if I go 2 times that y value is 0, still at 0, right? So the only thing that really affected it here is going to be our vertical translation of 5 up, right? So what will our range become? Y has to be... yeah, greater than or equal to 5, right? The whole thing just got, I know I got moved up 5. Okay, mapping notation, we'll do that one quick. So we'll say the mapping notation here would be any point x, y will turn into, and then our x's, so I'm looking at my horizontal stretch first, of a third. So is this going to go in as a third, or is it going to go in as 3 in my mapping notation? Yeah, it'll actually go in the same way, right? Because the mapping notation is what happened here. It actually had a horizontal stretch of a third. So the mapping notation will really be 1 over 3x. And then our horizontal translation will be also 1 over 3, so plus 1 over 3, comma. And then our y values have a vertical stretch of 2. So that's going to be 2y. And then a vertical translation of 5, so plus 5. There. Okay, like I said, that was all review probably, right? Okay. Let's do... okay. We're going to skip all the way down to this example. Okay, so this one says, Justin's physics textbook states that the speed s in meters per second of sound in dry air is related to the air temperature T in degrees Celsius by the function that. Right, we've got this big function. Now, determine the domain and range in this context. Okay, well, if we think about this, right, we're really kind of we're relating this to the base function y is equal to the square root of x, right, which we know looks like just generally starts in the origin and then goes up into the right. So then we're kind of looking at this being like, okay, well, what happened, right? Well, we could write this a little different. I think might make a bit more sense to us. What if we had it written like this? Like we'll rewrite this as S is equal to 331.3. And then I'm going to rewrite this again now as the square root of 1 over 273.15 t plus 1. Is everybody okay with that move? Yeah? That we all I did was rewrite this part of it a little different so that I can kind of see my well, I'm not actually seeing my b value yet, but I can see like what's happening. I know, like I kind of know what's happening here a bit more. It's looking like what we had going on before. So if we want to figure out, let's say our range part of this, so our range would be, any ideas? Kind of looking at this right now, looking at like what's happening here. Yeah.
Y has to be greater than or equal to 0.
Yeah, it still does, right? So y had to be greater than or equal to 0 in our original, and even though I'm like multiplying here, you can imagine all these numbers on this graph would be like multiplied by 331. I've got a vertical stretch, but what about where I started? That was 0 times that vertical stretch. That didn't do anything, right? And this graph doesn't have like a plus k value in the end. It's not moving the whole graph upward, right? This thing is staying at that. So the whole thing's being stretched upward, but it's still starting at that 0, 0. So we still just have y has to be greater than or equal to 0 for our range. All right, so domain, we're gonna have to do a little bit more work. To find our domain, we could figure out all the stretches and figure out where it went and everything there too. But the other thing we can do, what are you not allowed to take the square root of? A negative, right? So why don't we just like focus in on underneath the square root here and figure out what sets of numbers we're not allowed to use. So I'm going to start off by making myself a little equation. I'm going to say 1 plus t over 273.15 has to be greater than or equal to 0. And then we're just going to solve for t here. We're going to just do this inequality so that... So then I'm going to bring the 1 over to the other side, right? Subtract 1 from both sides. So I've got t over 273.15 has to be greater than or equal to -1. And then t has to be greater than or equal to, and I'm just going to multiply both sides by 273.15. So negative 273.15. And that's it. So now we know, so that's our domain, right? It has to be greater than that number. Anybody want to take a guess at what that number is based on the context of this question? Yeah.
0 Kelvin.
Yeah, absolute 0. Yeah. Have you guys, anyone taken chemistry, you've probably seen that before, right? That's like the coldest anything can be. All right, that's absolutely the coldest it can be, right? So this makes sense. It can't go colder than that because the equation just doesn't even work at that point, right? All right. So on the internet, Justin finds another formula for the speed of sound, and it's written like this. So now it says use algebra to show that the two functions are approximately equivalent. So the last one and this one. So if we started off with the other one, so I'm just going to write it again. Let's write down S is equal to 331.3. And now I'm going to write like a really big area for my square root for a second. And then it was 1 plus t over 273.15. Okay, so what I'm going to do, hopefully you guys are writing in pen too, is I'm going to rewrite this 1. Like I'm actually going to combine this whole thing over 273.15. So the way we add fractions is we put them over the same denominator, right? So why don't we write this 1 as 273.15 over 273.15. So then that would look like S is equal to 331.3 and then square root of 273.15 plus t. And then I'm just going to write it over a common denominator. I'm going to write it over 273.15. Is everyone okay with that? Yeah? Okay. So we just did that for a second. Now, do you guys remember, just a little bit of review on square roots, if I took the square root, let's say, of 36 over 9, is everyone okay with saying that that would be the same thing as 6 over 3? Like you just take the square root of the top, take the square root of the bottom. Yeah? So it'd be the same thing there. Or if I had the square root of, let's say, 37 over 49, something like that, then I could also write that. I could only bring out the 49 if I like. Right? But that would be the same thing as 1 over 7 times the square root of 37. You can like just pick the bottom and just take the bottom out. That works too. Or like take the square root of it. We're just going to do that same little trick here. We're actually just going to take the square root of 273 and pull it out on the bottom. Okay, so if we do that, that ends up being 331.3 over, and then the square root of 273.15 is 16.5. And then we're left with the square root of, and then 273.15 plus t. And then if I actually divide those two, we get an equation that looks like S, and I'm going to say is approximately equal to 20 times the square root of t plus 273, right? So we just kind of round 273. This was 273.15, but it ends up being the same thing there. Okay? Okay. How is the graph of this function related to the graph of the base square root function? So if I look at, okay, so the base square root function, you could write it as s is equal to the square root of t. And the function we're looking at is s is equal to 20 times the square root of t plus 273. Okay, well then we have a horizontal translation of what?
272 to the left.
Yeah, 273 left, and we have a vertical stretch of 20. Yep. Okay, next one. I'm gonna skip past this one. I think you guys would be all right with graphing this and finding it. So, and then these ones are really just plugging in numbers. So let's move past this one too, and move on to lesson 11.